gentlemen, the topic for discussion is smart signaling and control systems, enhancing safety, capacity, and rail network efficiency. A very, very critical subject. Earlier before lunch, there was a panel here, rail infrastructure development and modernization. When all is done, when we have your track down, we have your rolling stock ready, you now won't move if you don't have a signaling system to control the train movement. And we have come a long way. Paper orders, Fan Square, RTOS, now VDU, but the topic today is beyond all those systems which maybe didn't give us optimal efficiency. We are talking about smart signaling, because the capacity we have can be enhanced depending on the signaling system that we have, how efficient it is, whether you are able to see every train move and then giving it the authority to proceed or to stop, away from the old system where it was just a dark territory and you had to rely on the driver reporting his position. So let us go straight into this discussion, but first, I think our panelists just introduce themselves, their company, what they do, and then just to save time, you go into what you want to contribute to this topic. Do I have the mic? Who here have the mic? We'll start with you.
Hello, good afternoon, everyone. And thank you, Mr. Stevenson, for this interesting introduction. My name is Fabrizio Burro. I'm representing today WAPTEC Corporation. My role in the company is Director of Business Development and Project Management for the entire African area. My background is aerospace and defense first, and then the last about 20 years I spent my life in the railways domain, dealing with the African projects and African initiatives since 2008. I think that's no need to spend words for WAPTEC. I think that you know our company, multinational company, covering the entire railway landscape from the rolling stock and infrastructure point of view. And I'm pleased to leave the floor to my friend Richard.
Thank you, Fabrizio, and thank you, Stevenson. If people are tired of seeing you, I don't know what they're going to say about me, because I've been here a couple of times. So I'm not going to talk about either NJT and so on. I'm just going to say to Mabura that here is one of the elephants. I am not. My contribution to this panel would be a little bit, not controversial, but what we have listened about nearly the entire day today and yesterday is one subject which is a key factor to both increasing the safety, capacity, and rail network efficiency. And that is to secure funding into the infrastructure. Without funding into the infrastructure, nothing is going to happen. Even innovation has a cost. So it's both to the suppliers and to the railways. The railways need to understand that innovation has a cost. The suppliers, we need to understand that funding is an issue. And only together we can solve that subject.
Hi everyone, good afternoon. So my name is Rashad Nassar. I am Director of Global Business and Strategic Partners in Huawei. I worked for 10 years in Huawei and before in signaling companies like Siemens and Alstom. You know Huawei eventually. So we are top 6 innovative companies in the world. We reinvest actually 20% of our revenues, annual revenues, in research and development. Like last year, 120 billion US dollars. We invested 20% of them in research and development. My contribution will be mainly in terms of innovation, in terms of telecommunication part. We'll speak about how telecommunication will accompany signaling technologies like FRMCS. We will speak about it, about perimeter detection to enhance safety. So there are a lot of technologies that we are putting in. Actually, we are already deploying them in Africa. So we'd like to speak about that part. Thank you.
Thank you.
Good afternoon, everyone. My name is Pisman Sopazi. I'm the Regional Technical Manager based in KwaZulu-Natal. I work for the Railway Safety Regulator, and the region I'm responsible for is called the Eastern Region. I'm here to obviously represent the Railway Safety Regulator. So my role here is going to be to acknowledge that a lot of things have to be done. For example, the topic that we are talking about here has to do with anything that will assist with capacity management, train speed monitoring and control, real-time traffic conditions, and track and trace train location, dynamic reduction of train delays, remote management and control, and line optimization. So while we are aware that smart signaling involves all of that which I've just mentioned, my focus is going to be on looking at everything that we are doing as a system in terms of reliability, accessibility, maintainability, safety, and its sustainability, so that any proposed smart signaling systems conform to all those aspects. And then obviously looking at what the technology roadmap for signaling and telecoms in South Africa and in Southern Africa and across the borders should look like. And we are aware of many developments in this area, but I'll pause there for now. Thanks.
Thank you. Arasal.
Right, good afternoon, colleagues. Thank you, Chairperson. My name is Edward Mahwai, and I'm representing the Gautrain Management Agency. Where I'm going to be coming in the conversation is at the point of development and how development impacts the actual application of systems, and also how standards have to be conformed to in the development of systems, such that firstly reliability is sustained for the systems implemented, and in addition to that also the opportunity of additional maintenance and sustenance of services and systems that have been developed. That's my contribution. Thank you.
Okay, thank you. Maybe before you hand over the mic, I just want to Gautrain to say you are the 15 years or 18 years in operation, and obviously I think you have applied the latest signaling technology, not latest, but at least not a railway that could have been 100 years old. Can you share with us what is your signaling system like right now?
Thank you for that question, and I think I was going to lead with that to bring that to highlight. So we are using now what is called it was initially the Bombardier systems, and it is the city flow signaling system that we're using, and it's called the city flow signaling system. The advantages that this solution has is that it provides certain capability of data and opportunity of control in terms of the operations of systems. For instance, we have onboard train control systems, which is the ATP system, which is a watchdog for operations and ensuring that authorities and authorization movement is done under management, and also that on the signaling system itself, we have a reduction, albeit to some extent, a reduction of inclusion of line-side signals, because we also utilize balises, and balises provide forth what we would usually call the yellow signal or the infield signaling, and that provisions for lesser maintenance of roadside signals in the operation. But the by and large opportunity of the solution that we have is the ability of data that can be sourced in the system. And I think in addition to that is to say, there is an opportunity to increase this, to increase the capability of data for the system that we use. I think we will touch on the ETCS levels and what the additional ETCS levels, for instance, ETCS level 2 and ETCS level 3 solutions, which is still under development, will provide for. My colleague mentions communication. That's quite a key issue because communication is quite the backdrop or the backbone of an ETCS level 3 solution that also provisions for moving block solutions. I'll just end it there and then the colleagues can take it forward.
Thank you, Edward. And give the mic to Dr. Sopaz. As the regulator, we would like to know what are your requirements if you are going to, as a regulator, you issue permits for an operator, and I'm sure that in that process you also look at the signaling system or all associated communications that the operator will use to ensure, because you are a regulator, you are a safety regulator, very, very important. Would you say, give us some idea as to what are the key things that you look for in a signaling system if you were to be now evaluating and saying, yes, this operator has the right things in place?
Yeah, what a time to be alive. I'll just say that. You know, when Shamina was here, she spoke about integration of systems. And she mentioned that there would be a need for standards and regulations to manage, for example, open access. So that's exactly within our work. So to answer the question directly, what we look for is interoperability. Are the systems that are being proposed interoperable? And sometimes we also ask the question, are they interoperable? And also, are they conforming to predictable fail-to-safe states? Because while new technologies are being brought into the market, and we all acknowledge that an idea whose time has come cannot be stopped, we need to always remind ourselves about the basics and the fundamentals. So any technology that is introduced must be risk assessed from cradle to grave, basically, going through all the life cycle phases, from the feasibility studies, design, construction, testing and commissioning, and then we also want to know at the end of the life of that technology what's going to happen in terms of decommissioning that system and disposing it. So that's basically, in a nutshell, we conduct risk assessments. And then if the proposal of a new system satisfies all the conditions, then we are good to go.
There are many developers, there are many new systems, and obviously they've got to be tried somewhere. What would you say about, let's say, in this region or in Africa, or where you are in South Africa, trying systems? Would you give a permit for a new system, or you would require demonstrated, tested, systems to be introduced?
Yeah, as part of the risk assessment, we also want to know if what is being proposed has been tried and tested. And that's why I included in the life cycle phases testing and commissioning. And also, if a system is relatively new, we need to subject it to a rigorous process of risk assessments and asking questions and making until we are convinced that it is going to not just be a system that we are all excited about, but that has inherent problems. So when all of that is done, then would be able to accept it. So the way we approach our work is that we don't intend to be a technical barrier to trade, but we just want to make sure that whatever is used in the country and across the borders, in cases where we interface with our neighbors, it will be safe and has been tested.
Okay. Thank you for that response. Rochard, you are in communication, and you tell us more your involvement, because obviously signaling systems in communication, telecommunications, I think they go hand in hand. So, but we can expand a bit more in the rail sector.
Yeah, thanks. Actually, as I mentioned earlier, we are leader in telecommunication part, but actually I would like to compliment on what have been said. I'm happy that I'm the third one to speak to hear from you, because you mentioned one point is the ETCS point, and the second one is interoperability. And us on our telecommunication part, we speak about interoperability. We would like to push for standards technologies. Because when we want to make sure that we're crossing borders, or we want to be interoperable between different railway operators, we need to go with a standardized approach. And the International Railway Organization, the UIC, put a standard, international standard called the ETCS that has been mentioned. And we are speaking about ETCS level 2, now we're speaking about ETCS level 3, which is more advanced, to reduce the number of equipment on the track side, actually, and move towards more automated approaches. And to build that, you need a telecommunication, train-to-ground communication system. And now the new standard, international standard, is called the FRMCS, the Future Railway Mobile Communication System. Most of you actually have heard about GSMR eventually. This is the 2G for railway. And this one is becoming obsolete, and now the new standard is the FRMCS, has been issued the FRMCST last year, and now they are in progress. There are actually some African countries that already starting deploying it. We have South Africa with Brazza. We have also Mozambique, the Goba line, they are doing that. And other countries now, they are moving in that direction. So this is, it's not just to the sake of changing technologies and moving from one technology to another. There is an advantage of it, because we are speaking about how signaling will enhance the capacity, will enhance the efficiency, enhance the safety. And the FRMCS with the ETCS on top of it will help to increase the capacity, because we are passing from a GSM 9.6 kilobit per second towards several megabit per second, 20 megabit per second. It's a broadband technology, train-to-ground communication technology. So that will allow us, and you mentioned that, we pass from what we call the fixed blocks towards what we call it moving blocks. So we get trains closer to each other with a dynamic end of authority and dynamic speed curves. Getting more trains on the track increase the capacity. So for example, on Goba line, we pass from 3,600 tons per day towards 7,200. So we double the capacity. That's a good return on investment for the railway operators. And not only efficiency, we are speaking about safety. So for example, you can, with the 4G, with the 5G, with the broadband technology, you can detect any abnormal behavior on the driver, because he can be sleeping, he can be on his phone or something. You can detect that in real time. We can increase, also we can do multimedia dispatching. We can do a lot of things on top of a broadband technology. So this is a very interesting solution, and it's a standardized solution. So it's very important for crossing borders to make sure that railway operators will use similar technologies. And another one that I would like to mention quickly is perimeter detection. This is what we are doing here, is we are using artificial intelligence. You know, Huawei have our own machine learning techniques, our own systems for AI, and AI is revolutionizing a lot of industries. And we can see that transportation system is at a turning point in terms of AI investments. And we are here to accompany railway operators, because it's a big jump. A lot of people are afraid of AI. A lot of people were afraid of cloud 10 years ago. But now everyone is by default having a lot of things, images, photos, everything in the cloud. Same for AI. It's becoming part of our daily business, actually, daily life. And we would like to accompany railway operators to go into this digital world with AI, with smart scenarios, solving real issues to enhance efficiency and capacity and enhance safety. So perimeter detection is one of them to prevent intrusions and detect intrusions. You know, there are a lot of vandalism on the track, a lot of stealing of equipment, a lot of accidents because animals are crossing. And this is common for all countries, actually. And here what we are doing is with using AI with optical sensing, with fiber optics, and AI cameras, combining them in order to detect in real time any intrusion. Okay. There are a lot of solutions. I can spend 3 hours speaking about solutions that Huawei can provide, but we are here accompanying you step by step to move towards this digital era. Thank you.
Thank you, Richard. Richard, I would like you to comment or contribute on the railways. They've got different operating systems, or let's say signaling systems. Now, when we are the association here in SADC, we're actually looking at corridor routes, the international trains, the cross-border operations. Of course, there are internal movement of trains in big countries like, let's say, Mozambique and South Africa. However, the different railways are at different, development stage of technology absorption. Okay, one railway in a particular corridor, a section of the corridor, could be moving faster, investing into smart signaling. The others, the other two in the rest of the corridor could not be, or they're behind. How are we going to optimize on the efficiency we are looking for, or the capacity enhancement? Richard?
Oh, that's a good question. I would say initially, railways suppliers need to stop thinking, I have the best solution. Why do we reinvent the wheel in countries? Has nothing to do with the African continent. It's the same in Europe. It's the same in the North America, Southern America, in Asia. All countries, all railways are reinventing the wheel. The suppliers are reinventing the wheel. I kind of disagree with the gentleman here who says, well, we can use this kind of telecommunication. Prior to coming into the railway industry, I worked in the telecommunication. And it's not rocket science. Today, we hear about the FMCS, the new kind of modern standard. That will be old in 2 years from now. And it's still not even on the testing stage. So if you have a communication system that works, why do you put patches and patches and patches and patches on top of that just because someone has developed some new hardware? I said earlier today, stop talking about 5G. Talk about XG. Because 6, 7, and 8 are already in play. Okay, not commercially, but they are still there. And that's just innovation on the hardware side. Because the bandwidth and the communication on our globe is the same. AI? Well, I don't have anything in the cloud. None of our data is in the cloud. Why? 1, I don't trust. 2, I don't trust. So we have to stop reinventing the wheel. We have to.
All right. Let me give Fabri. If time permits, you'll get time.
Thank you.
But let me give. All right. The signaling, all those things, of course, cost money, but they're investment for improving. If we don't invest, then we are not going to improve capacity, safety, all the things, all the good results we are looking for. So whilst whatever you want to comment, do touch on saying the cost of all these things. Yes, it's a cost, but it's an investment for our improvement. Fabio?
Yeah. Thanks for this question. And I mean, I have the privilege to be the very last in this first turnaround. And I would like to answer your question to attach to what my friend Richard just said. Going back to answer your question, I would like to go back to the theme of this panel is the making everything safe and smart. Assuming that we always put safety first.
Priority.
Let's focalize on smart. To do smart things for the infrastructure managers and the operators, as railways industries technology provider, we have to start thinking smart as first. So we have to start thinking smart to deliver smart things. And I have to I need to subscribe what Richard just said about the tendency we had in the past to reinvent the wheel and invent technology in the railways domain. That made increasing a lot costs, time for implementation required, and maintainability, scalability, because the fact that we invented telecommunication in the railways in the far 80s and 90s, as Richard, I'm European, so I know very well the history, at least for that continent. That really prevented the railway stay at the state of the art. And I would like to reattach to what Johnny Smith said before about we tend to be years and years late than the other. So my idea is that to make smart things, let's start thinking smart. Let's start detaching the non-railway scope from the railway scope. As railway, we have to focalize on real railway things like how to make interlocking better in the past, how to make the ATP more efficient and safe, how to make the ATO, the automatic train operation, safe and efficient, and taking from the market what it comes from the telecommunication. And I don't want to speak only about terrestrial telecommunication. Satellite communication today is even more performing than any 5G, and Richard is right when he says we have to think about XG. We can speak about artificial intelligence, cloud, digital map on board, and I'm glad to hear that the team here is aligned on the reduction of the wayside components. The future, or I would say the present, because from the WAPTEC point of view is already present and we can already do that. The present is strongly on-board centered signaling systems, reduced and minimized wayside systems that will reduce the CapEx and the OpEx for our infrastructure managers and operators. Let me complete in saying that another aspect that can make things smarter is the scalability. We have to be, as industry, capable of matching the use cases of our customers and not imposing our preferred technology we developed by ourselves because we are railways and we require to reinvent the wheel every time. And to do that scalability, we have to consider that in the same country, in the same region, we have to be capable to deliver in one stretch, in one line, a pure, simple, dark territory solution, or we have to be capable to overlay on any nice existing relay interlocking that we want to maintain. This is newly saving money, or where required, we can be capable to deliver standalone, very modern, vital, fully electronic system, as the colleague rightly said before, characterized by moving virtual block for enhancing the capacity. So changing the mindset of the railway people will make things going better in the sector, I think.
Thank you for that. Let me give Huawei there. And I'm running out of time, but submit your comment, your contribution.
No, it's not a comment, just a clarification.
And this will be your concluding mass as well.
Yeah. So, no, just to clarify on the FRMCS, I understand. Actually, it's normal that 4G, 5G, it's true. I mean, when 6G, 7G, 8G, it's true. But that's actually, it's taken into consideration in the standard. So when UIC and railway operators worldwide has come to discuss what is after GSMR, there was 4G at that time, 3G at that time. There was 4G after, now 5G. So they say, I don't want each time telecom operators follow and move, and suppliers move from 5G to 6G to 7G, I need to change all my infrastructure. I don't want that. It costs me a lot. So what they've done is that they make standard interface. So in that case, when you move from 4G to 5G to 6G to 7G, your signaling system on the train, you don't have to go refurbish them and change them and do all the rechange of all the signaling infrastructure. So this is already taken into consideration in the standard. And there is another thing, please disrupt. I mean, for me, I don't agree that we need to stay like we has to been for 30 years. A lot of governments, financial, all of them are moving already to the cloud, are integrating AI. In the next 5 to 10 years, you will see AI in everywhere. You will see AI doing big scientific discovery. We cannot be afraid. We cannot have this penguin dilemma that we are afraid to jump because we don't know. Okay. No, there are other sectors, industry, that already crossed this line and moved towards cloud, moved towards AI. And why, for example, AWS, Microsoft, not only Huawei, big international companies, American companies, Chinese companies, they are leading in the world in terms of revenues. Why? Right. Because people trust them, because people trust their data with them. Actually, in terms of cybersecurity, it's more secure to put your data with cyber experts who are doing a lot of research and development, anticipating cyber threats, than putting your data in an IT department who doesn't have that expertise. And I'm not speaking about the cloud to put the data in China or US. I'm speaking local. I'm speaking about South African data centers. Okay. I'm speaking about sub-Saharan data centers. And Huawei is the first to invest in data centers inside Africa, to put data centers inside Africa, to keep the data in Africa, in South Africa. Yeah.
Thank you. Dr. Sopaz, your concluding remarks?
Yeah, I just want to say that regardless of the direction we take as the regulator, we have a delicate balance to manage, and that is to, on the one hand, not over-regulate, on the other, to not under-regulate. The reality is that the world is changing, so some systems may well be becoming obsolete. So one has to appreciate that and be willing to embrace new technologies. But before a technology is introduced, like I've said, we have to do proper feasibility studies. We have to understand what is wrong with the current technology before we move to the next one. Thank you.
Okay, thank you. Edward, 1 or 2 words?
Yeah, thank you very much. I think for me, my take is to afford interoperability, we need standards to conform such that multiple systems, multiple units that are used on same infrastructure are used while retaining safety, but improving capacity. Thank you.
Thank you. Gentlemen, Richard, would you forgive me because I've run out of time? 1 minute. Well, I've got a stopwatch.
No, I just want to kind of, I will allow myself to have the closing mark.
Okay.
And I would say that the railway safety regulator, they have a nearly impossible job. I am myself an international certified quality auditor, so I know exactly kind of what you guys are doing. Writing standards, putting standards in place is an impossible task, nearly, because you need to do all the nitty-gritty, let's say, admin, writing, verification work, and then you need to keep up with the development of technology. And that is a task in itself. When I mentioned the cloud and the AI, obviously, all technologies, even ours, is based on machine learning. What I want to say to this panel, to this audience, is AI, what is it? What is the definition of AI? Because in my opinion, it is kind of like become a little bit of populistic kind of abbreviation. Everything is AI. AI is a solution for everything. But what is it really?
Okay. All right, at this point, I would like to thank our panelists for the contribution. They have much, much more, but with the time limitations. We are here on smart signaling for efficiency improvement, for capacity enhancement, safety being one of the key things that we want as railway operators here. So it is something that we must pursue. Let us engage with the panelists so that we don't remain where we are, but we move forward in terms of increasing capacity and in terms of safety. Let us give them a hand of applause.